A sample proportion is just the percent of the population. So for example, in a survey, 25 out of 124 people surveyed said they preferred to eat green M&Ms instead of red M&Ms. So the percent of the population is going to be 25 over 124. So 25 divided by 124 is about 20%. So that's just a sample proportion. A margin of error is a sample proportion should be reported with an estimate of error. So margin of error means, okay, we surveyed 124 people, but we don't know how everybody's opinion is about green M&Ms versus red M&Ms. So we're just going to sample a part of the population. So in this case, the margin of error can be actually quantified. We can actually put a number to the margin of error. So it's a margin, which means that it can be positive or negative, plus or minus off the percent. So I'll do an example to illustrate that. So the larger the sample size, the lower the margin of error. So an example would be if you're trying to figure out the percent of the population that's left-handed. If you just ask people in a classroom, you might only have one person that's left-handed, or you might have nobody that's left-handed, but actually in the world it's estimated that 7% of the people are left-handed. So the more people you ask, the more likely you're going to get closer to that 7%. So to find the margin of error of 150 people, we're going to use this formula. So the margin of error is going to be plus or minus 1 over the square root of the population, which is 150. So if I calculate 1 divided by the square root of 150, I get 0.08. So that is approximately plus or minus 8%. So second example, what sample will give you a margin of error of plus or minus 6%? So what you want to do is you want to do 0.06 is equal to 1 over the square root of n and solve for n to figure out the population size. So to solve for n, I'm going to multiply both sides by n, or the square root of n, which will cancel out this side, and this side will be the square root of n. So I have 1 equals 0.06 times the square root of n. Now I can divide by 0.06. So if I do 1 divided by 0.06 and then square that number, to get rid of the n squared, I'll get approximately 278. So the population that will give you a margin of error of plus or minus 6% is asking 278 people. So second one, I'm going to do, it's 3%, so I'm going to do 0.03 equals 1 over the square root of n. I'm going to multiply both sides by the square root of n. Then I'm going to divide both sides by 0.03. So I get the square root of n equals 1 divided by 0.03, which is 33 1/3. So I keep this in my calculator, and then I'm going to square it. So I'm squaring this number to get rid of the square root. So that is approximately 1,111 people that you'd have to survey. So the margin of error and sample proportion go together. So here's an example. If you ask somebody if you asked a group of people a question and you got 56% of the people said an answer, you would figure out your margin of error, which would be 3% in this picture example. So you would, the likely interval would be from 53% to 59%. So you can use the margin of error and the sample proportion to find the likely interval or likely range of the true population proportion. So the more people you survey, the less your margin of error and the closer you're going to get to the actual population. So it's called likely range because it's not always true. So that's something that kind of happened with the election in 2016 for the presidential election. The actual result was outside the margin of error, so that's why people were surprised about the election. So an example, in a survey of 150 people, 40 would like to have later hours available. So I'm going to do 40 divided by 150. So 40 divided by 150 is about 27%. So I'll put about 27%. That's our sample proportion. So our margin of error is going to be the number of people that we ask, 1 over the square root of 150. And remember, it's plus or minus. Don't forget to put the plus or minus. So I calculate that, and that is approximately 8%. So the likely interval would be take 20% and add 8%, which would give you 35%, and then take 27% and subtract 8%, which would be 22%. It would be 19%. So the likely interval would be 19% to 35%. So even though you asked and you got 27%, you're going to have to, the likely interval would be 19 to 35%. So anybody outside of that, it would kind of be surprising if you took everybody that goes to KDL and asked them and they said, 50% of them would want later hours available. That would be surprising. So example 1, in a survey, participants were asked to their opinion of the new government program. Which sample was the largest? So we've kind of already talked about this before, that the lower your standard deviation is, the larger the population is. So it'd be the sample C because the population or the standard deviation is lower. And bias in sampling methods, sometimes there's biased sampling. So I'm going to go through each one and describe whether or not it would be biased and suggest something else. So a committee wants to find how much time students spend reading each week. They ask the students as they enter the library. I would say that's biased because they are having kids that already go to the library. So if you go to the library, you're more than likely to be reading, or interested in books. So therefore it's biased. So one way they could do it is they could just ask people at a school. They could interview all different types of people at a school. Second one, the students planning the junior class party want to know what kind of pizza to buy. They ask the pizza restaurant what kind sell the most. I think that is a good idea. So I wouldn't say this one was biased. Because they just want, generally, high school juniors are probably going to order the same type of pizza that other people in the community would order. The county road department wants to know which roads cause the most concern among the residents of the county. They asked the local restaurant to hand out survey forms. I also think that that's probably a good idea, except for if you're asking just a local restaurant, then you're only going to get maybe people, well, it depends. You'd have to think about what the population is of the local restaurant. Do old people go and younger people go? Does it cater only to a certain type of population? If it caters to all populations, then I would say that's not biased. And the last one, a politician wants to know the voters' views on an important issue. She has her campaign workers call people randomly from the phone book. In this case, I would say this is biased because not many people have phone books, so you might be getting an older population. So it's important to also to seek out people by text messaging or emails as well. Okay, example 3, find the sample size. So if the sample, I'm going to do one of these. So if the margin of error is 15%, you're going to do 0.15 equals 1 over the square root of n. So you're going to multiply both sides by square root of n and divide this side by 0.15. So then you end up getting square root of n equals 1 over 0.15, and then you need to square both sides. So 1 1 divided by 0.15 squared is about 44. So about 44 people. For each sample, find the sample proportion, the margin of error, and an interval likely to contain the true population proportion. Round to the nearest percent. So in a survey of 38 parents of preschool children, 20 would like to have their school district provide playgroup sessions at least one evening a month. So the sample proportion is going to be 20 out of 38. So 20 divided by 38 is 53% because I'm rounding to the nearest percent. The margin of error is going to be 1 over the square root of 38, plus or minus. Don't forget to put the plus or minus in. So it's going to be 1 divided by the square root of 38. So it's plus or minus 16%. So the likely interval is going to be 53 minus 16, which is 37%, to 53% plus 16%, which is 69%. Okay, letter B. In a random sample of 526 visitors, 378 want the craft center to be open later in the evenings. So the sample proportion is going to be 378 divided by 526. So I do 378 divided by 526, and I get about 72%. So I rounded. The margin of error is going to be plus or minus 1 over the square root of the population that I surveyed, which is 526. So 1 divided by the square root of 526 is about plus or minus 4%. So my likely interval is going to be 72% minus 44%, which is 68%, to 72% plus 4%, which is 76%. And the last one, in a survey, this doesn't need to be here, in a survey of 165 visitors, 102 want the library to have more novels available. So sample proportion is going to be 102 over 165. So 102 divided by 165 is 62%, approximately. The margin of error is going to be plus or minus 1 over the number surveyed, 165, with the square root. So 1 divided by the square root of 165 is about 8%. So I'm going to put plus or minus 8%. So the likely interval is going to be 62% minus 8%, which is 54%, to 62% plus 8%, which is 70%.